Assalamu alaikum, my dear students. How are you? Hope all of you are well by the grace of Almighty Allah. Welcome to NIABS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School Day Shift. Today I am going to take a physics class for class 9 students. My dear students, our today's topic Chapter 7, Reading Done Part 2, our lecture number 25 and SW number 22. Let's start our class. This is Chapter 7. Waves and sound. Infrasound. Now at first we will discuss about infrasound. If the frequency of sound is less than 20 Hz, it is called infrasound. My dear students, I am repeating, what is infrasound? If the frequency of sound is less than 20 Hz, it is called infrasound. Next, ultrasound. If the frequency of sound is greater than 20 kilohertz, it is called ultrasound. If the frequency of sound is greater than 20 kilohertz, it is called ultrasound. My dear students, you have to memorize these two definitions. Now, the sound that can be heard is frequency between 20 Hz to 20,000 Hz or 20 kilohertz. It is known as audibility range. What is audibility range? The sound that can be heard has frequency between 20 Hz to 20,000 Hz or 20 kilohertz. It is known as audibility range. And if frequency less than 20 Hz or greater than 20 kilohertz it is generated, then the movement created in air will not be heard by us. That means only we can hear from 20 Hz to 20,000 Hz. Okay, frequency. Now, characteristics of sound wave. Characteristics of sound wave. Sound is a mechanical wave because sound wave is produced due to the vibration of body, and for its transmission an elastic medium is needed. This is a longitudinal wave because the direction of propagation of the wave and the direction of vibration is the same. My dear students, why sound wave is a longitudinal wave? This is a longitudinal wave because the direction of propagation of the wave and the direction of vibration is the same. The velocity of sound depends on the property of the medium. The gaseous medium, in gaseous medium its velocity is low, in liquids greater, and in solid it is much more. My dear students, this is important MCQ, important for MCQ. In gaseous medium the velocity of sound is low, in liquids is greater, and in solid it is much more. Now, intensity of sound. Intensity is the amount of sound energy flowing per second per unit area perpendicular to the direction of propagation of sound. My dear students, this is important definition. What is called intensity of sound? Intensity is the amount of sound energy flowing per second per unit area perpendicular to the direction of propagation of sound. Now, what is meant? This is a short question. What is meant by intensity of sound? 25 W per meter square. What is called by this? Sound intensity 25 W per meter square means that 25 joule sound energy flows per second perpendicularly with the direction of sound amplitude through 1 meter square area. Okay, my dear students, this is important short question answer for 2 marks. So, what is mean by intensity of sound 25 W per meter square? Now come to echo. What is echo? If a sound wave is obstructed in a far away medium and comes back to the source, then the repetition of the original sound is said to be an echo. This is another short question answer. Why do birds not fly during the daytime? Answer: birds can produce and hear sound of frequency ranging from 1 kilohertz to 100 kilohertz. That means this is ultrasound. Okay, they fly using the echo of sound as they cannot see. This is why birds do not fly during the daytime. Okay, now we'll discuss variation of velocity of sound. In air, velocity of sound is proportional to the square root of temperature, that is V proportional root T. In air, velocity of sound is the velocity of sound is proportional to the square root of the temperature, that means V proportional root over T. Here the temperature is in Kelvin scale. The velocity of sound does not depend on the air pressure, but it is inversely proportional to the square root of the density of air. So if they are in water vapor in the air, its density decreases and hence velocity increases. Now here given the velocity of air in the different medium. The velocity of sound in air medium is 330 meter per second. My dear students, at first you have to memorize this table properly, and this is very, very important for MCQ. The velocity of sound in air medium is 330 meter per second. The velocity of sound in hydrogen medium is 1284 meter per second. In mercury, the velocity of sound is 1450. In water, the velocity of sound is 1493 meter per second, and in iron, the velocity of sound is 5130 meter per second, and in diamond, the velocity of sound is 12,000 meter per second. And now musical sound. What is musical sound? Those sounds which are usually produced by the regular and periodic repetitions of source and we consider as sweet are musical sound. And the three characteristics of musical sound are loudness or intensity, pitch and timbre or quality. Okay, now we will discuss what is pitch. The characteristics of musical sound by which the sound of the same intensity is sometimes heard, dull and sometimes sharp. It is called pitch. And what is timbre or quality? The characteristics of sound by which we can differentiate the sound produced from different musical instruments is called timbre or quality of sound. Now sound pollution, we have already learned this topic in our previous class. Sound pollution is the excess sound that causes adverse reaction in our body, and mind is noise pollution, this is called noise pollution, and the intensity of different types of sound are shown in the table. Jet engine 110 to 140 dB, traffic 80 to 90 dB, car 60 to 80 dB, television 50 to 60 dB, and conversation 40 to 60 dB, breathing 10 dB, sound of mosquito wings 0 dB. My dear students, now we will solve some mathematical problems from your book. Okay, see here problem number 1. Here given two figure. This is the amplitude in x-axis. They are given position in meter, and this is amplitude in meter. Okay, this is the origin, that means 0. This one is 0.1 and this one is amplitude plus 0.1 and this is minus 0.1. This is a position 0.5, 1, 1.52, and this is a wave. Okay, this is a wave. And from here to, my dear students, we know from here to here this complete wave. This is a complete wave. Okay, now see this second figure. Here also given the amplitude in y-axis and x-axis time. Okay, in the above figure, a wave at a particular time in different position and for a particular positions in different times. Okay, determine its amplitude, wavelength, time period, frequency and velocity. My dear students, this is the stem. This is the stem, and the question is we have to determine its amplitude, wavelength, time period, frequency and velocity. My dear students, see here given from first figure. Here given the amplitude. Okay, amplitude A is 0.1. Here given amplitude for first figure, amplitude given 0.1. Okay, here amplitude given 0.1 meter, and here also given the wavelength lambda. Here given wavelength lambda equal to 1 meter. Okay, this is wavelength. From this is a complete wave. This is the wavelength here given 1 meter, and from second figure here given the amplitude also, here also given amplitude. This is the for first figure and this is for second figure. Amplitude here given 0.1 meter, here given time period. This is the wavelength and this is given time period. Time period is for complete wave, here given time period 0.2. Time period T, we indicated time period by T, capital T, and here given 0.2 second. Okay, we have to find out frequency and velocity. Frequency f equals to what and velocity v equals to what. Okay, now my dear students, in our previous class we have already proved that f equals to two relation, f equals to 1 divided by t and another v equals to f lambda. Okay, from here, from use this formula, now we will find out the frequency. Frequency equals to 1 divided by f equals to 1 divided by t. Here given time period t is 0.2 second. Here given time period t 0.2 second. So 0.2 1 divided by 0.2 equals to 5 hertz. The unit of frequency is hertz. Now this is the frequency, and here now we will find out the velocity. Velocity equals to f lambda. Here we already found the value of frequency is 5 hertz, and in lambda given here, lambda means wavelength, wavelength given 1 meter. So 5 into 1 equals to 5 meter per second. This is the velocity of sound. Okay, now come to problem number 2. Problem number 2. Sound of frequency 1 kilohertz is produced by a tuning fork. It was allowed to pass through air, water and iron. It was found that the velocity of sound in air is 334 meter per second. In water it is 1493 meter per second, and in iron 5130 meter per second. What are the wavelength in this medium? My dear students, this is very easy mathematical problem. Here given, see, here given the frequency is 1 kilohertz. Frequency f given 1 kilohertz, that means 1 kilo, that means 1000 hertz. Okay, now velocity given in air, for in air medium, velocity here given 334 meter per second. In next water, in water velocity given, suppose V2. Okay, for water suppose V2 1493 meter per second. Here given the also sound air of iron medium. In iron medium here given 5130 meter per second. Now we have to find out the wavelength of this medium for air, water and for iron. Okay, suppose in air medium we know V equals to f lambda. So suppose this is V1, V1 is equals to f lambda. So we have to find out the wavelength, that means lambda, lambda equals to V1 divided by f. That means here V1 given 334 meter per second divided by f given 1 kilohertz, that means 1000 hertz equals to 0.334 meter. This is the wavelength for air. Okay, this is the wavelength for air. For air wavelength is 0.334 meter. My dear students, like this we will find out the wavelength of water, that means V2 equals to f lambda, then lambda equals to V2 divided by f, and then we will can easily find out the wavelength of in iron medium, that is lambda 3 equals to V3 divided by f. We will use this formula, V equals to f lambda. Okay, now problem number 3. At a certain place the temperature in the water winter 10 degrees centigrade and velocity of sound is 332 meter per second. If the temperature is raised to 30 degrees centigrade in the summer, what is the velocity of sound? Answer, my dear students, now we will solve problem number 3. Problem number 3, now we will solve. Here at first write, here given temperature T1, first temperature. The temperature in the winter, that means this is the first temperature, that means 10 degrees centigrade. My dear students, we will convert this centigrade into Kelvin now. Okay, so 10 degrees centigrade. We will convert this centigrade into Kelvin. So we have to add with 273 with 10. This now it is Kelvin. Okay, 273, that means 283 Kelvin. And we also, the T2 temperature T2 is 30 degrees centigrade. That means we also convert this centigrade into Kelvin. That means 30 plus 273 Kelvin. Okay, so it will be 303 Kelvin. And here given velocity for first medium, velocity V1. Suppose this is V1, and we are given 332 meter per second. 332 meter per second. We have to find out the velocity of next V2. V2 equals to what? My dear students, we have already learned this formula, that V proportional root over T. V proportional root over T. Use this formula. By using this formula, we will solve this problem now. So we can write V1 divided by V2 proportional root over T1 divided by T2. Okay, we have to find out the value of V2 now. So we can write, sorry, this equals, it will be equals. So we can write V2 equals to V1 divided by V2 equals to root over T1 divided by root over T2. Then we can write by cross multiplication, we have to find out V2. So V2 into root over T1 equals to V1 root over T2. Now V2 equals to V1 root over T2 divided by root over T1. We can write like this. So the value of V1 equals to 332 into root over T2. T2 means 303 divided by T1 means 283. By doing this calculation, we will find 343.5 meter per second. This is the answer. This is the velocity. Okay. My dear students, our your today's SW number is 22, and your SW is this mathematical problem number 1, 2 and 3. And you have to submit it on Saturday. My dear students, I hope all of you have understood our today's topic. Memorize properly this all definitions, question answer, and practice properly this mathematical problem. See you again in the next class. Allah Hafiz.